For months now, the sky has been waiting. Above the noise of cities and the glow of our restless world, something has been moving. Slow, silent, and impossibly distant. Astronomers call it 3I Atlas, the third interstellar object ever detected. But to most of us, it's just a name, a string of letters, a mystery hidden in the dark. When it first appeared on the radar, scientists thought it would behave like every other comet, a frozen traveler from beyond, just passing through our solar system on its long, lonely journey. Its orbit looked predictable, its speed familiar, everything about it said ordinary. But space has a way of keeping its secrets until the very last moment. Because as 3I Atlas drifted closer to the sun, something started to happen. The first signs came quietly, a faint flicker in the data. At a small observatory in Chile, a team of graduate students noticed it first. They thought it was a glitch, a flickering reflection in the telescope feed, maybe caused by atmospheric distortion. But then the same flicker appeared in Hawaii, and again in southern Spain. 3 observatories, 3 continents, one impossible pattern. At first, the pulse was barely visible, a shimmer in the light curve that rose and fell like a heartbeat. Every 72 seconds, the brightness dipped, then spiked, dipped, and spiked again. Regular, precise, intentional. If it were a random object reflecting sunlight, it would scatter light unpredictably. But this looked like rhythm, like something was pulsing from inside. Astronomers ran simulations, rechecked equipment, recalibrated sensors, again and again. Yet no matter what they did, the pulse remained. It wasn't the telescope. It wasn't the software. It wasn't human error. It was the comet itself. Soft music builds. A low, tense note under the narration. One astronomer, Dr. Saito from Kyoto University, described it best. It's as if the object is breathing, and it just started noticing us. Her words spread quietly among the scientific community. Most dismissed them as poetic exaggeration, but deep down, everyone felt it. That quiet unease that comes when data starts to look alive. By late September, 3I Atlas was already halfway to perihelion, the point in its orbit where it would pass closest to the sun. That's when the flicker became stronger. At first, it was a faint whisper in the data, a curve bending where it shouldn't. Then, within weeks, it became a repeating pulse strong enough to measure across multiple spectrums. Visible light, infrared, even radio. The pattern was consistent, 72 seconds apart, every single time. If this were a normal comet, the light curve would change gradually, brightening as the sun heats its surface, melting the ice into gas, creating that glowing tail we know so well. But this object wasn't following the rules. Instead of growing brighter, it dimmed. Instead of heating up, it cooled down. The closer it came to the sun, the quieter it became, as if retreating from the light. It was supposed to be predictable. But 3I Atlas was writing its own script. Pause. Sound of a soft cosmic pulse fades in. Heartbeat rhythm, 72 seconds apart. There's something unsettling about watching the sky and realizing that something out there might be responding. The data felt almost personal, a pattern you could anticipate, like tapping your finger to a rhythm that doesn't belong to you. Some scientists began calling it the signal, half-jokingly. Others stopped joking entirely. Because when patterns repeat perfectly, when the timing never slips, never wavers, never drifts, it starts to feel less like coincidence and more like communication. In interviews, you could hear the disbelief in their voices. They'd seen distant galaxies, neutron stars, even the flashes of gamma bursts across the void, but never a comet that behaved. Not like this. It's showing feedback, one researcher said. It's reacting to sunlight in ways no natural object should, another whispered. Off record. If this were a probe, we'd never know. The sentence hung in the air for days. NASA's Jet Propulsion Lab released an official statement, brief and cautious. We are observing non-random fluctuations in reflectivity from object 3I Atlas. Further data is required to determine cause. But behind that polished language, the tension was rising. Because Non-random, in the language of science, is just another way of saying pattern, and pattern means intent. Music shifts, slower, colder, echoing. By early October, 3I Atlas had entered the inner solar system. Its surface temperature began to behave strangely. Instead of the expected rise from solar radiation, infrared sensors showed intermittent cooling, as if something on or within the object was regulating its heat. That shouldn't be possible. Not for rock, not for ice, only for systems that adapt machines. Around this time, a small network of amateur astronomers began live streaming the object's movement online. In the dark hours before dawn, thousands of people watched through grainy feeds as a single bright dot crept across the sky. No one could see the flicker, not with the naked eye, but knowing it was there changed everything. It wasn't just a comet anymore. It was something else. Something that made people look up and wonder who, or what, might be looking back. Back in Chile, the first team that noticed the anomaly kept recording. For 16 straight nights, they tracked the same 72-second pulse. Then, one night, it stopped. The flicker vanished. The light curve flattened. Atlas went silent. At first, they thought it was interference. But when every other observatory confirmed the same, total silence, a chill spread through the scientific community. Had it shut down, or had it finally finished whatever it was doing? In the following days, something even stranger began to appear. Minor fluctuations in its orbit, small deviations that couldn't be explained by gravity or radiation pressure alone. It was subtle, barely measurable, but it was there, a shift, a deliberate one. Soft hum rises again, a sense of motion, uncertainty. For decades, humanity has looked to the stars for answers, but sometimes the answers don't arrive as words. They arrive as silence, as patterns, as questions that make us feel both smaller and closer to something vast. Atlas kept moving, quiet, unbothered, heading straight toward its moment of truth, perihelion, the point where it would meet the full force of the sun. Whatever it was made of, whatever it was doing, we were about to find out, or so we thought. Music fades into a distant pulse, echoing like a heartbeat lost in deep space. Narrator softly. Sometimes, silence isn't the end of the story. Sometimes, it's the beginning of something that finally starts to speak. And 3I Atlas was just beginning to whisper. At first, they thought it was a glitch, just a flicker, a thin line of light that shouldn't have been there. Most comets brighten gradually as they near the sun, a smooth rise in luminosity as frozen gases ignite and form their long, glowing tails. But 3I Atlas didn't follow the script. It didn't rise. It didn't flare. It blinked. The first time it happened, the data team at Mauna Kea thought their system had lost calibration. The brightness dropped, then spiked, dropped, and spiked again, exactly 72 seconds apart. The same rhythm, over and over, repeating through hours of observation. It wasn't noise. It wasn't a glitch. It was deliberate. When the data came in from Chile's Cerro Tololo Observatory, they checked it against the Hawaiian feed. Same pattern, same timing, same impossible pulse. By the third confirmation, a private facility in Spain, the whispers began. What could make a comet blink like that? Soft hum deepens, like the slow breathing of the cosmos. In normal cases, a comet's light curve, the chart that maps its brightness over time, looks like a gradual wave, smooth, predictable, and almost poetic in its simplicity. But the 3I Atlas light curve didn't look like a wave. It looked like a code, a series of repeating peaks and valleys, spaced with machine-like precision. Every dip aligned perfectly with a spike in infrared emission. Every flash coincided with a small release of heat, and the rhythm never changed. Not once. Dr. Lina Alvarez, a data analyst from the European Space Agency, described it like this: "If nature made this pattern, it's never done so before." The phrasing was careful, neutral, but beneath it was something else, a feeling of disbelief, of awe, of quiet fear. Because when science meets perfect rhythm, the human mind starts to ask forbidden questions. At NASA's Goddard Center, teams ran the data through multiple systems. They ruled out cosmic rays, sensor drift, solar interference, every usual suspect. Nothing explained it. Finally, a small sub-team proposed the simplest explanation: rotation. Maybe 3I Atlas was spinning unevenly, reflecting sunlight like a disco ball. Bright one moment, dim the next. It made sense. For about an hour. Then came the problem. If the comet were rotating that fast, its structure would tear apart instantly. The forces would shred it into dust. And yet, it remained intact. Music softens, a slow, suspenseful hum. One scientist, a quiet radio astronomer named Dr. Marcus Leclerc, decided to test something unusual. He converted the brightness data into sound, a process called sonification, to see if the human ear could detect hidden patterns. When he played it through the lab speakers, the room went still, because what they heard didn't sound random. It was rhythmic, consistent, almost musical, a low, steady beat, repeating every 72 seconds, like a pulse in the dark. That night, Leclerc wrote in his private notes, "This object behaves like it's sending, not reflecting, sending." He never said it publicly, but those words found their way into internal reports. And within days, research centers across the globe began cross-checking every available wavelength, from radio to ultraviolet, searching for hidden modulation. They found faint patterns everywhere, flickers, pulses, heat waves, all aligned, with the same impossible timing. By now, the news had reached the public. A few lines buried in a European astronomy bulletin mentioned periodic optical fluctuations in the interstellar object known as 3I Atlas. The article was small, but the headline spread like wildfire across the internet. People began calling it the blinking comet. Forums buzzed with theories. Some said it was magnetic interference. Others thought it was reflecting solar storms. A few whispered something else entirely, that maybe it was trying to communicate. Of course, no one in the scientific community would say that aloud, but privately, they wondered, because this wasn't the first time light had behaved this way in deep space. In 1967, a similar pulse was detected from a distant radio source, rhythmic and perfect. Scientists called it LGM-1, short for Little Green Men. Later, it turned out to be the first discovered pulsar, a rotating neutron star, a natural explanation, a comforting one. But this wasn't a star. It was a small frozen traveler from another system, and it was blinking. Soft strings fade in, delicate and haunting. For astronomers, this was a turning point. The light curve, that familiar graph they'd studied all their lives, had become something alien, something alive with pattern and purpose. They started to notice smaller details. The pulse wasn't perfectly uniform every 24 cycles. There was a faint shift, a slightly longer pause, a flicker of increased reflectivity. It was subtle, but real, a pattern within the pattern, like punctuation. At the European Southern Observatory, a senior astrophysicist gave a quiet interview. "If we were looking for a signature of intelligence, this would be step one, periodicity," he smiled nervously. "But we're not looking for intelligence. We're looking for physics." That distinction between physics and intelligence was beginning to blur. Because what happens when the physics itself starts to act intelligent? By mid-October, observatories began working in shifts, tracking 3I Atlas around the clock. Every few hours, the pulse data came in, unchanged, unwavering, indifferent to time zones or theories. And then, something new appeared. A faint afterglow following each flash, a secondary emission that shouldn't have been there. It was delayed by exactly 0.3 seconds. No natural process could explain that. Delay, it looked like feedback, a response. The hum grows deeper, darker, a low, mechanical thrum. When 3I Atlas finally crossed the 1 AU mark, roughly Earth's distance from the Sun, the pulse began to intensify. The light grew sharper, the rhythm steadier, almost focused. It was as if the object were aligning itself, positioning, preparing, but for what? Behind closed doors, agencies shared encrypted data. There were hushed calls between NASA, ESA, and JAXA. No official statement was made, not yet, but in a leaked memo, one line stood out: the possibility of an artificial modulation source cannot be ruled out. That phrase, artificial modulation, was all it took. Conspiracy channels exploded. People claimed it was an alien probe. Others said it was part of a solar experiment gone wrong. But for the scientists, one truth was more terrifying than any theory. If this pulse wasn't artificial, then it was something else entirely. Something new. Something our models had never predicted. Music slows, a sense of wonder and unease mixing. In the end, every story about discovery begins the same way, with disbelief. The human mind looks at the unknown and tries to make it fit what it already understands. But 3i Atlas refused to fit. It wasn't obeying our rules. It wasn't following our math. It was writing its own, and as it drew closer to the sun, steady, cold, and blinking in that eerie rhythm, one question began to echo through every observatory in the world. If this isn't just reflection, if it's not a trick of light or rotation, then what is it? Silence. The hum fades. One final 72-second pulse echoes, slow, deliberate, and haunting. Narrator, quietly: the comet that shouldn't blink just did, and it wasn't done yet. When the data first came through, no one believed it. The light pulses weren't just visible, they carried heat, tiny bursts of infrared radiation, perfectly timed, perfectly synchronized. Every 72 seconds, a flash, a heartbeat, a whisper of energy. And for the first time, astronomers began to realize this wasn't light reflecting off ice. This was something transmitting. At the European Space Operations Centre, teams stared at the data in silence. When they layered the light curve over the thermal readings, the alignment was exact. Every brightness spike matched a microburst of infrared energy. Not random, not scattered, not natural. It was controlled, like the object was talking in temperature. Dr. Lena Alvarez, who had once dismissed the flicker as an optical illusion, sat frozen at her console. "This isn't physics as we know it," she whispered. "It's behavior." The word hung heavy in the room. Behavior. It implied choice, intent. And that idea that something drifting through the solar system might be choosing to release energy sent ripples through every research center on Earth. Soft pulse sound fades in, a low thump repeating at 72-second intervals. When the signal was isolated and slowed down, it revealed layers, faint modulations, tiny fluctuations hidden within each burst. To the human eye, it looked simple. But to the trained ear, when converted into sound, it was mesmerizing, like a distant beacon echoing through empty space. Each pulse rose and fell like breath, as if the object were alive, adjusting, communicating. But with what or with whom? At NASA's Jet Propulsion Lab, data scientist Dr. Marcus Leclerc revisited his old sonification model, the same one that had first exposed the rhythmic pattern. He fed the new thermal data into it, and what he heard chilled him. A perfect duet, the visible light pulsing in one tone, the infrared heat answering in another. Together they formed a synchronized harmony, like two instruments playing in time. No natural comet had ever done that. By now the object was closer to the sun than Mars. Its surface should have been boiling, disintegrating into gas and dust. But it wasn't. Instead, 3i Atlas was cooling itself. The infrared bursts appeared to counteract solar heat, radiating energy away in rapid micropulses, maintaining an even temperature despite increasing solar pressure. It was regulating, deliberately, like a machine keeping itself alive. Soft, tense strings fade in, the tone of awe and disbelief. The more they studied it, the less sense it made. Infrared imaging revealed strange fluctuations across its surface, hotspots appearing and disappearing in geometric patterns, hexagonal, symmetrical, organized. Each shape aligned with the heat bursts, as if panels on the surface were opening and closing, radiating energy in perfect rhythm. One analyst described it as a mechanical heartbeat, but no one dared say the word that hung in everyone's mind: artificial. At the European Southern Observatory, a late-night briefing gathered specialists from 5 countries. They sat in silence as the thermal map rotated on the screen, a cold, glowing mass blinking with precision against the black of space. Then, in a quiet voice, a young technician asked the question everyone had been avoiding. Could it be listening? The room went still. Because what if it wasn't sending a signal? What if it was responding to one? Music slows. An airy, suspenseful tone builds. Teams began comparing the rhythm of 3I Atlas's pulses with cosmic radio background noise, solar activity, and even deep space communication frequencies. One correlation stood out. Every time the sun released a burst of high-energy particles, a small flare, a spike in solar radiation, the object pulsed back, 72 seconds later, almost as if it was answering. At this point, scientists began running controlled simulations. What if the object was reflecting solar energy intentionally? What if each pulse was a form of adaptive shielding, or, worse, a way of learning the sun's rhythm? The data didn't reject the idea. In fact, it supported it. By now, 3I Atlas had captured the imagination of the world. News anchors spoke of it as the living comet. Online forums filled with theories, some scientific, some far from it. A few called it a probe, others a message. Some even suggested it was an ancient machine crossing the stars, waiting for us to notice. But scientists stayed cautious. They didn't use words like alien or artificial. They used safer words: unexplained, anomalous, active. Yet everyone knew what those words really meant. Soft hum rises, a sense of approaching revelation. In the coming days, the pulses began to shift. The interval stayed steady at 72 seconds, but the shape of the heat spikes changed, longer, sharper, more complex. They formed clusters, like syllables, like code. Mathematicians began analyzing the intervals, translating them into binary patterns, zeros and ones, silence and sound. The first line they decoded sent chills through the room. It wasn't a random sequence, it repeated, a pattern within a pattern, as if the object were testing communication. At the SETI Institute, one researcher compared the data to past radio signals. No match. Not pulsars, not quasars, not interference. Whatever this was, it was unique. Something had traveled across interstellar space, reached our solar system, and now it was talking, soft, deep tone, like the breath of a machine in the dark. But to whom? Was it calling home, responding to the sun, or was it reacting to us the moment we started watching? Some began to wonder if the timing of its pulses had changed right after Earth's first observations. They checked the logs, and yes, the modulation had shifted, subtly but unmistakably. Right after our first telescopes locked onto it, it had noticed. Silence. A slow heartbeat rhythm continues underneath. For the first time in history, humanity might be staring at something that wasn't just a rock or a comet or an accident of nature. It might be a design, a creation, a messenger built for endurance, precision, and awareness. But awareness of what? Of energy? Of gravity? Of us? No one could answer. Not yet. In one of his last interviews before the data was classified, Dr. Leclerc said something that stayed with people for years. If you listen closely to the signal, it sounds almost like it's breathing. And when something breathes, it means it's alive, or it remembers what life feels like. Music softens, a deep, emotional note builds. Atlas continued to pulse, steady and unbroken, as it moved closer to the sun. Each cycle seemed to feed on the last, as if it were gathering power, preparing for something that none of us could see coming. And in the quiet rooms of observatories across the world, scientists sat awake through the night, listening to the heartbeat of something that shouldn't exist. A signal from the dark, a pattern without a name, a voice that might not be ours. Narrator, softly. If it's truly answering something out there, the only question left is, what happens when that something answers back? At perihelion, the point of closest approach to the sun, every known comet should burn. It's the climax of their journey. The heat strips away layers of ice, releasing brilliant tails of vapor and dust that stretch millions of kilometers across space. But not this time. Not for 3I Atlas. When the object swung into the sun's gravitational grip, the world's observatories prepared for a spectacle, a violent flare, a brief but magnificent death. Instead, the light curve fell silent. Brightness dropped. The expected plume never appeared. And then, something impossible happened. The object began to cool. At NASA's Solar Dynamics Laboratory, engineers thought the instruments had malfunctioned. They recalibrated, cross-checked, rebooted. But the readings didn't change. A cold front, a literal pocket of darkness, had formed around 3I Atlas, defying the radiation storm that should have vaporized it. Temperature maps showed the surface dimming below expected thresholds, not warming, but freezing. As the sun's rays struck its surface, they seemed to vanish, absorbed and neutralized by something unseen. Dr. Lena Alvarez stared at the data in disbelief. "It's not evaporating," she said quietly. "It's protecting itself." The room fell silent, because that single word, protecting, changed everything. No natural object had ever demonstrated such behavior. No comet, no asteroid, no icy body had ever resisted the sun. But 3I Atlas wasn't resisting. It was adapting. Soft background tone builds, a hum like circuitry warming up. Infrared imaging revealed geometric cold zones forming across the surface. Precise hexagonal grids, evenly spaced, cooling in waves. Each one pulsed faintly with energy before dimming again, a rhythmic cascade sweeping across the object's exterior. The signature resembled a heat dissipation network. In other words, a cooling system, not chaotic, not random, engineered. At the European Space Agency's thermal lab, scientists modeled the anomaly. They found that the only way to replicate the readings was if the object's surface emitted a form of active infrared counter-radiation, releasing energy to neutralize incoming solar heat. Essentially, it was generating a shadow against the sun, a cold field. And if that was true, it meant the object possessed control over thermodynamics, over light, perhaps even over physics itself. Narrator, soft, awe-filled. The sun, the most destructive force in our solar system, was being resisted. Not through luck, not through composition, through design. As the object approached perihelion, something else happened, something stranger still. The rhythmic pulses detected earlier, those 72-second intervals, began to sync with solar activity. Every flare, every burst of radiation, every pulse of light. It was as if 3I Atlas had locked onto the sun's heartbeat, mirroring it, harmonizing with it, adapting in real time. The object's cooling patterns even intensified moments before each solar flare, as if it knew what was coming. Music fades, replaced by the faint rumble of solar winds. At the Institute for Planetary Physics in Tokyo, Professor Hiroshi Tanaka described it best. "It's not fighting the sun, it's listening to it." His team discovered microdelays between solar activity and 3I Atlas's temperature drops, precise to the millisecond. The object wasn't merely reacting, it was anticipating. To test the theory, researchers compared historical solar data to the object's behavior. They found that during every increase in solar output, even before the radiation reached it, 3I Atlas was already cooling down. It predicted the sun's energy bursts seconds before they occurred. That kind of preemptive adaptation required information, knowledge of its environment, perhaps a sensory system, or something far beyond that. By now, scientists across the world had stopped calling it a comet entirely. In classified memos, it was renamed The Object, a neutral title, one that avoided conclusions but hinted at the unknown. Publicly, press releases remained cautious. Unexplained thermal regulation observed, possible outgassing delay, unusual non-gravitational activity, but behind closed doors, they knew none of those explanations fit. Atlas wasn't reacting like rock or ice, it was behaving like technology. Subtle electronic tones rise, reminiscent of distant communication. Then came the shockwave. During a 14-minute observation window, instruments aboard the Parker Solar Probe registered a distortion in the solar magnetic field, a faint but measurable pulse originating from the object itself. It wasn't an explosion or a flare, it was a broadcast, a low-frequency modulation radiating outward, synchronized perfectly with the cooling wave pattern. It wasn't just resisting heat, it was using it, converting solar radiation into a form of transmission. At the same moment, radio telescopes on Earth picked up something faint, a background hum buried within cosmic noise. When filtered through the same algorithm used to decode 3I Atlas's thermal rhythm, the hum matched perfectly, two signals identical. Originating from opposite sides of the Sun, Atlas had sent something through the star, not around it, through it, as if the Sun itself were part of the mechanism. Narrator. Low, grave. It wasn't running from the Sun. It was using it, harnessing energy, transmitting data, operating with precision no human technology could match. And for the first time, scientists began to question whether this object's path toward the Sun was intentional, a trajectory chosen long before it ever entered our system. As the object passed perihelion, it should have fractured or burned away completely. Instead, it emerged intact, smaller, darker, quieter, but still pulsing. Thermal sensors detected faint residual patterns, complex waveforms looping across its surface, decaying slowly, like the dying echo of an engine cooling after flight. It had survived the Sun, unaffected, unchanged, and yet transformed. Back on Earth, Dr. Leclerc reviewed the post-perihelion data and whispered the words that would later define the mystery. If this thing can regulate heat like that, then it's not just surviving space, it's built for it. Music softens, the hum of the cosmos deepens. As 3I Atlas drifted away from the Sun, its temperature stabilized once more. But something new appeared, faint electromagnetic emissions, pulsing in a strange, irregular pattern. It wasn't the 72-second heartbeat anymore. It was slower, deeper, almost like breathing after exhaustion. Scientists realized that if the previous rhythm had been communication, this new one felt like hibernation. It was conserving energy, or perhaps waiting. Narrator. Final tone, calm and foreboding. Whatever 3I Atlas is, it doesn't fear the Sun. It uses it, understands it, endures it, and as it drifts back into the darkness of deep space, no one knows if it's gone dormant or if it's simply preparing for whatever comes next. By the time 3I Atlas had passed perihelion, most thought the event was over. The anomaly had peaked. The danger, if there ever was one, had faded into silence. But silence, in space, is never simple. Because sometimes, silence hides an echo. Weeks after 3I Atlas began drifting back into the outer system, a quiet alert appeared at the Deep Space Network control room in Canberra, Australia. A junior technician noticed a rhythmic pulse in the data stream. Faint, repetitive, barely distinguishable from background noise. Every 72 seconds, he flagged it, logged it, and for a moment dismissed it as solar interference, until another station, halfway across the planet, saw the same thing. At the Goldstone Observatory in California, the same pulse emerged. Then again, at the Madrid complex, 3 different stations, separated by continents, connected only by the ecliptic plane, all detecting the same rhythmic hum, repeating perfectly in phase. It wasn't just background static anymore, it was structure, pattern, purpose. Narrator, slightly hushed, building intrigue. The signal wasn't coming from the sun. It wasn't coming from Earth. It was coming from between them, from the dark corridor where 3I Atlas had just passed. At first, scientists proposed the safe explanation, plasma interference. The solar wind sometimes bends radio frequencies, reflecting them along magnetic lines. But those echoes fade unpredictably. This one didn't. It was steady, timed, consistent to the millisecond, like a clock or a code. At the European Space Operations Center, researchers began correlating the echo with the original light curve data from months earlier. To their disbelief, the rhythm matched exactly, the same 72-second interval first seen in the comet's brightness before perihelion. That pattern, once dismissed as a coincidence, was now echoing across the solar system. Soft ambient tones rise, resembling a slow transmission hum. In Tokyo, a data analyst named Mei Kobayashi overlaid the thermal pulses from 3I Atlas with the new radio echoes. When she aligned the peaks, something clicked. Each radio burst was delayed exactly 6 minutes from the original thermal pulse, the same delay you'd expect if a signal had traveled outward from 3I Atlas, reflected off something beyond the asteroid belt, and returned. But there was nothing there to reflect it. No spacecraft, no debris field, no known source of interference, just empty space. Narrator, low, almost whispering. And yet, the echo was answering. As the signal strengthened, more observatories joined the search. Arecibo's successors in Puerto Rico, the Atacama Array in Chile, and China's massive fast telescope all confirmed the same phenomenon, a single repeating pulse, orbitally synchronized with 3I Atlas's path. It wasn't drifting randomly through the void. It was tracking the object's movement, as if maintaining a link. Some began calling it the tether, others called it the reply. By now, private discussion forums among scientists had turned into quiet panic. If the signal wasn't a reflection, if it wasn't interference, then there was only one possibility left. It was being transmitted, deliberately. Inside NASA's Jet Propulsion Lab, a small team formed under a temporary directive called Echo Study Group. Their mission: decode the pattern. The first attempts failed. They tried binary, Morse, prime sequences, even spectral mapping. Nothing made sense, until one evening, a researcher noticed that every 8th pulse was slightly weaker, not in frequency, but in phase. When plotted, it formed a waveform that resembled a heat signature, a miniature version of the thermal pattern 3I Atlas had displayed near perihelion. It was as if the echo was repeating the comet's behavior, remembering it, narrator, softly, reflective. A comet shouldn't remember, it shouldn't repeat, it shouldn't echo anything. But 3I Atlas wasn't just reflecting light anymore, it was reflecting itself. As the weeks went on, the echo grew louder, faint but steady. The Deep Space Network could now isolate it from background noise. And when they applied spectral analysis, they found something chilling. The signal contained harmonic layers, frequencies stacked precisely at ratios found in engineered communication systems. The odds of that occurring naturally, less than 1 in a trillion. Still, publicly, agencies called it unconfirmed electromagnetic interference. Behind the scenes, though, the emails told a different story. One message leaked weeks later read simply, "The source demonstrates intelligent modulation." At that point, scientists began to argue over what the echo actually meant. Some said it was residual energy from the object's interaction with the sun, a plasma aftershock vibrating through the heliosphere. Others suggested 3I Atlas had emitted a signal that was bouncing between planets, refracting through solar wind. But then came the silence. Background sound, pulse slowly fades, replaced by static. On the 32nd day of observation, the signal stopped. No fading, no distortion, just gone. It vanished mid-cycle, between 2 peaks, as if cut off, intentionally. The data stream went flat, Technicians thought the receiver had failed. It hadn't. Every array across the planet confirmed the same thing. The echo had ended, simultaneously, everywhere. In the moments that followed, researchers sat frozen before their monitors, staring at empty graphs. The hum that had haunted them for weeks was gone, replaced by silence so heavy it felt like the air itself had stopped moving. And for some reason, that silence felt louder than the signal ever did. Narrator, low, tense. Was it a transmission completed, a system shutting down, or a conversation ended? No one could say. But the timing was unmistakable. Exactly 1 hour after the final pulse, 3I Atlas crossed beyond Mars's orbit, leaving the inner solar system behind. The moment it did, the signal died. At a late-night briefing, one researcher said something that would never make it into the public record. It wasn't sending us a message, he said quietly. It was calling home. Music softens, faint reverb echoes like a final pulse fading into distance. In the months that followed, 3I Atlas continued outward, silent once again. But every now and then, radio astronomers still check the deep frequencies, listening for that familiar rhythm. Nothing yet, just background static. But they say, sometimes, if you listen long enough, you can almost feel the next pulse coming. Almost, narrator, final, lingering. The echo is gone, but its memory remains, a pattern written across the ecliptic, traced between the sun, the planets, and one impossible traveler. Maybe it was plasma interference. Maybe it was something else. Either way, the sky remembers, and somewhere beyond Mars, something is still listening. When 3I Atlas crossed beyond Mars's orbit, scientists expected it to fade quietly, another cold rock retreating into the dark. But instead, something changed. Its surface began to shimmer. In the weeks after the echo stopped, deep space telescopes turned their eyes once again toward the object. They wanted to confirm it was still stable, still following its predicted path. But what they found defied everything. The object's reflectivity, its albedo, wasn't constant anymore. It was shifting. Soft, suspenseful underscore builds. At first, the change was subtle, a few percentage points of brightness lost and regained between rotations. But within days, the pattern deepened. Every time 3I Atlas completed one full spin, its light signature changed, brighter on one side, darker on the next, like a mirror turning to hide its reflection. Astronomers compared the data and found that its brightness didn't follow any natural scattering model. The surface wasn't reflecting sunlight. It was controlling it. Dr. Hanna Moretti from the European Southern Observatory described the discovery in a single sentence that sent chills through the entire team. It's not reflecting light, she said. It's choosing how to be seen. Narrator, low, resonant, choosing. The word carried weight. Because if 3I Atlas could alter its reflectivity at will, then it wasn't just reacting to its environment. It was making decisions. Spectral analysis revealed something even stranger. The regions that dimmed most weren't ice or rock. They showed signatures of metallic compounds, unknown alloys with ultra-high reflectance in narrow wavelengths. In other words, engineered materials. They appeared and disappeared mid-rotation, as if sections of the surface were shifting in and out of visibility. To some, it looked like camouflage. To others, a warning. Sound. Faint mechanical modulation fades in, the suggestion of movement, of machinery turning slowly in the dark. Dr. Kian Patel at NASA's Infrared Research Division noticed that the surface didn't just reflect light, it bent it. When sunlight hit 3I Atlas, it refracted unnaturally, scattering into polarized arcs before disappearing completely. That's when someone used a word no one wanted to say out loud: adaptive surface. In the defense world, that means one thing: a skin that can change shape or color based on its surroundings. But this was no aircraft, no satellite. This was an object from interstellar space, and it was hiding itself. For a week, the readings continued. The object's brightness fluctuated in a perfect cycle. Every 12.4 hours, the same reflective pattern repeated. Then suddenly, the rhythm broke. The next observation showed an entirely new signature. Brighter, smoother, colder. It had changed again. This time, not just reflectivity, but composition. At the European Space Agency's spectral lab, the new data revealed traces of chromium, titanium, and something else. A dense metallic compound with no known terrestrial match. The structure was crystalline yet conductive, designed to reflect not just visible light but radiation. Whatever this shell was, it wasn't just protection, it was function, it was purpose. Narrator, measured, tense. The object wasn't disintegrating like a comet should, it was rebuilding. But rebuilding what? On a conference call between NASA, ESA, and JAXA, the debate turned heated. Some argued it was natural, a surface reaction from solar stress, a crystallization of exotic ices. Others weren't convinced. Dr. Mei Kobayashi, the same analyst who discovered the echo delay, ran a simulation of the reflectivity map. When plotted in sequence, the bright and dark patches formed a repeating spiral pattern. Not random, not chaotic, symmetrical. She overlaid it against the pulse data from earlier chapters in The Mystery, and what she found made her heart stop. The spiral shape matched the 72-second pulse frequency, translated into spatial form. The same code, but written across its skin. Soft, electronic pulse resumes. Faint, rhythmic, 72 seconds apart. Narrator, softly, almost whispering. It wasn't gone. It had just changed medium. The pulse had left the radio bands and moved to the surface. The team stared at the screen. Each rotation of 3i Atlas revealed the code shimmering faintly across its body, a silent transmission written in light, but no one could read it. Some thought it was a signal, meant for observation, something to be seen, not heard. Others believed it was internal, a feedback mechanism, perhaps even communication between layers of its own structure. If so, then 3i Atlas wasn't just a vessel. It was an active system, maybe even alive. At the University of Cambridge, astrophysicist Dr. Rafiq Morgan gave an interview that was never officially aired. He looked directly into the camera and said, "The surface behavior we're seeing, the reflectivity shift, it reminds me of adaptive camouflage, like a machine adjusting its skin. The question is not what it's hiding from, but who it expects to see it." Narrator, deep, cinematic pause. Who it expects to see it. That sentence haunted everyone who heard it. Because in all the data, there was one consistent theme: anticipation. Atlas always acted one step ahead. It anticipated the sun. It anticipated the heat, and now perhaps it anticipated observation, as if it knew it was being watched. Sound, low-frequency rumble builds, like the resonance of light bending. Then, during one rotation, something extraordinary happened. For a brief 14-second window, the object's albedo spiked beyond measurable range. Telescopes saw nothing but a white flare, and then complete darkness. When vision returned, 3i Atlas had changed again. Its entire surface now reflected no light at all. It had turned black, perfectly matte, perfectly invisible against the backdrop of space. The last trace of sunlight slid off it like oil. Narrator, slow, quiet, ominous. The object had erased its reflection, like a shadow learning how to disappear. Over the next few days, every instrument lost lock, radar, optical, infrared. All failed to capture its signal. Only a single magnetometer aboard a distant probe registered the faintest whisper of energy. A pulse, slow, deliberate, traveling away from the sun. It was moving faster now, faster than before, and some said, if you mapped its path carefully enough, it no longer followed the expected outbound arc. It had changed direction, slightly, but deliberately, as if adjusting course. Narrator, final, reflective, from a bright traveler of ice to a dark mirror of metal, from a silent object to something that might be watching back. Whatever 3i Atlas truly is, its story is far from over. It came shimmering in light, and now it leaves cloaked in shadow. And as it fades beyond the reach of our instruments, we're left with one haunting question. Was it hiding from us, or preparing for something we haven't seen yet? For days, astronomers waited, eyes fixed on empty space, screens filled with static and silence, when 3i Atlas slipped behind the sun. It was supposed to be just another predictable eclipse. 31 hours of blackout. That's all. No telescope could see through the glare. No radio dish could pierce the solar noise. But this silence felt different. Usually, when a comet rounds the sun, its signal fades. Sure, but background static, solar interference, and radiation signatures still hum faintly through the instruments. This time, there was nothing. Not even background noise. It was as if something, or someone, had turned it off. Scientists tried to reassure themselves. They said it was the sun's corona, or cosmic noise, or instrument fatigue. They told themselves it was fine. But inside every observatory, every mission control room, every sleepless researcher staring at those blank lines of telemetry, a quiet unease began to grow. The world had gone still around 3I Atlas, and no one could explain why. When it finally re-emerged from behind the sun 31 hours later, the first image came through from the Solar Dynamics Observatory, and what they saw made no sense. The Atlas was not where it should be. Its trajectory had changed, ever so slightly, but measurably, like it had been nudged, pushed. The object had moved off its original orbit by several thousand kilometers. Not much, astronomically speaking, but impossible, given what was known. Gravity couldn't do that. Solar winds couldn't, either, and the sun's radiation pressure, even at full blast, wasn't enough to alter its path so precisely. So what did? Inside NASA's Jet Propulsion Lab, a late-night meeting was called. Half the room believed it was a data misalignment, a glitch from light delay and recalibration. The other half stayed quiet, staring at the numbers, because deep down, they knew the math was perfect, every measurement matched, every variable accounted for. The deviation was real, and worse, it looked intentional. When they reanalyzed the data from before and after perihelion, something even stranger appeared. During the blackout, 3I Atlas had decelerated. It slowed down against the pull of the sun. That's not supposed to happen. A comet approaching perihelion should accelerate, whipped around the sun by gravity like a slingshot. But 3I Atlas resisted. It behaved like it was controlling its own movement. Imagine a rock drifting through the void for millions of years, suddenly deciding to apply brakes. No one wanted to say it out loud, but the silence in the room said enough. Meanwhile, in the hours after the re-emergence, a handful of amateur radio astronomers reported something eerie. Just before the object reappeared from behind the sun, they caught a spike in narrowband static, faint, rhythmic, and familiar, a pulse repeating every 72 seconds. Then, it was gone. It lasted less than 2 minutes, but the timing matched exactly, the window right before visual contact. It was as if the object had announced its return. When the official reports were released, the public only saw a cleaned-up version, a simple statement from NASA, trajectory deviation likely due to outgassing or sublimation effects near perihelion. But every professional who studied those readings knew there was no outgassing. Infrared sensors had detected no heat, no vapor plume, no debris tail. Atlas hadn't expelled anything, it had simply changed direction. By now, the whispers had spread beyond the labs. Conversations moved into encrypted channels, late-night conference calls, and anonymous forums where astronomers spoke carefully, almost fearfully. One researcher described it as behavioral, another compared it to a maneuver. And yet, no one could prove a thing. There were no clear signals, no signatures of propulsion, no energy burst, just a shift. Subtle, silent, impossible. Still, the data didn't lie. Something had moved it. In the days that followed, telescopes tracked 3I Atlas as it drifted further from the sun. Its brightness flickered once, faintly, then again, that same 72-second rhythm. But this time, the flashes were slower, like a heartbeat fading into sleep. No one knew if it was losing power or just falling quiet again. The silence returned, heavy and absolute, and this time it stayed. No more pulses, no more reflections, only a cold trail of light, drifting toward the edge of the inner solar system. For the scientists who had followed it since discovery, that silence felt almost personal, like the end of a conversation they didn't know they were having. One astronomer, in a rare interview, described it best. It wasn't noise we were detecting, it was presence. And then one day, it decided to stop talking. Weeks later, when the last signal file was archived, someone noticed something odd, a pattern in the timestamp metadata. The 72-second pulses, when translated into binary intervals, formed repeating triplets. Nothing obvious, nothing that spelled words, but symmetrical, balanced, structured, almost written. To this day, no one knows what moved 3I Atlas in the dark. Some say it was solar radiation, others a complex spin-out effect, but those who stared longest into the silence, the ones who watched the data vanish line by line, still wonder, because maybe it wasn't moved by the sun, maybe it moved away from it, and if it did, what exactly was it trying to avoid? The leak came quietly, just a few pages of a classified European Space Agency report. It shouldn't have reached the public, but it did, and once it did, nothing felt the same again. The document's language was cautious, almost academic, but one line stood out, clear as day. I-Atlas exhibits behavioral patterns consistent with an engineered mass responding to solar input. Engineered. That word alone was enough to divide the scientific world in half. At first, the leak was dismissed, a hoax, a misinterpretation, another internet rumor. But then, journalists confirmed the file's origin. It was real. An internal draft circulated between ESA's Solar Research Division and the European Southern Observatory. Inside, the data spoke louder than any theory. The report detailed how 3I Atlas's spin rate had changed in perfect synchronization with solar radiation flux, as if it was adjusting itself to sunlight, not reacting, responding. The object's rotation wasn't chaotic, like a natural body tumbling through space. It was controlled, measured, intentional, and that changed everything. Within hours, major observatories began running independent simulations. The results were unsettling. When they modeled 3I Atlas as a natural comet, the numbers fell apart. Its shifts in trajectory, temperature, and reflectivity didn't fit the equations. But when they treated it as a solar reactive mechanism, something capable of directing or absorbing energy, the data aligned almost perfectly. It was as if 3I Atlas wasn't fighting the sun, it was using it. At NASA's Planetary Science Division, the mood grew tense. Dr. Elaine Sorensen, one of the lead analysts, described it this way. We were looking at the sun as the experiment, but suddenly it felt like the sun was the trigger, and 3I Atlas was the subject. They began testing theories that bordered on science fiction. Could solar photons act as propulsion? Could reflective panels, or something like them, redirect heat for controlled movement? Each answer opened another question. If this object was controlling itself, then who built it? And what was it doing here? The machine hypothesis, as it came to be called, spread fast. Some scientists dismissed it as paranoia. Others, quietly, admitted that the data didn't lie. One team in Germany went further. They created a simulation where 3I Atlas functioned like a light sail, shifting its orientation to manipulate solar momentum. It matched observed data within 3% accuracy. But when they tried to present it to ESA leadership, the project was shut down within days. Funding suspended, access revoked. The reason? Data uncertainty. But behind closed doors, a few insiders knew the truth. The results were too good, too clear, too dangerous to confirm. In online forums, amateur astronomers began connecting dots that professionals wouldn't dare mention. The synchronized pulses, the heat regulation, the altered trajectory, the sudden silence. Together, it painted a single terrifying possibility. 3I Atlas wasn't a visitor by accident, it was sent. Across the Atlantic, the SETI Institute quietly restarted dormant programs to scan for narrowband signals in the 72-second range. Nothing was found. At least, nothing they were willing to share. A month later, a journalist from Le Monde published another leak. An email between ESA scientists debating whether 3I Atlas could be a passive probe designed to activate near-stellar energy sources. In one reply, a senior physicist wrote, "If this is artificial, it's not communicating with us, it's listening." That single line, "it's listening," sent a chill through everyone who read it. Because suddenly, humanity's role in this story shifted. We were no longer observers of a distant object. We were the observed. Talk shows, podcasts, and online communities exploded with speculation. Was 3i Atlas a derelict probe? A beacon? A seed from an ancient civilization? Scientists tried to hold the line, reminding the public that evidence was still inconclusive. But each new observation only deepened the mystery. Spectral scans revealed structures, faint, repeating patterns on the object's surface that looked too regular to be random. Reflectivity maps showed consistent geometric angles, and when 3i Atlas passed near Mercury's orbit, a brief pulse of electromagnetic interference knocked out 2 radio observatories for nearly 8 minutes. Coincidence? Maybe. But to those watching closely, it felt like more than that. The machine theory fractured global opinion. To some, it was thrilling, proof that we were not alone. To others, it was terrifying, evidence of something we couldn't understand or control. And for the small group of scientists who'd been tracking the object since its discovery, it was personal. They had watched it blink, they had watched it shift, they had watched it move through the solar system with purpose. And now, they were forced to confront a question no one was ready for. What if this wasn't the first time something like this had come here? Because buried deep in the ESA archives, one analyst found something strange, a reference to another anomaly, decades earlier, an object that appeared briefly in solar observation data from 1977, same orbital pattern, same reflective signature, then gone, no official record. Remained, but the coordinates matched the same sector where 3i Atlas first appeared, almost like it had been here before. And if that's true, if this thing had passed through once already, long before we had the instruments to notice, then maybe it wasn't visiting us at all. Maybe it was returning. When the first samples of spectral data came back, no one believed them. The isotopic ratios were wrong, not just unusual, impossible. Every element in our solar system, every grain of dust, every drop of water, carries a familiar chemical fingerprint, the same handful of isotopes forged in dying stars billions of years ago. But 3i Atlas, it carried something different, ratios of heavy metals that didn't match any known cosmic source elements, forged under conditions we've never seen, in pressures and temperatures that shouldn't even exist in this galaxy. For weeks, laboratories across the world rechecked their instruments. Maybe the sensors were contaminated. Maybe solar interference had skewed the readings. But one by one, the tests confirmed the same thing. Atlas was made of matter from somewhere else. The first to go public was Dr. Wen Li, a materials physicist from Beijing Observatory. In an interview, her voice trembled slightly as she said, "These isotopes are not from our sun, not from any nearby star, and not from any region we can currently map. They come from a different chain of stellar evolution." When asked what that meant, she hesitated, then quietly said, "It means we're looking at something older than our galaxy." The data pointed toward a strange conclusion. The isotopes weren't formed in a typical supernova. They came from an asymmetric collapse, a kind of stellar death that shouldn't produce solid matter at all, and yet, here it was, a tangible object crossing our skies, built from atoms that predated our sun, and maybe the Milky Way itself. As scientists ran orbital simulations backward through time, the trajectory of 3i Atlas began to stretch farther and farther into the void, until it led to a place with no name, a dark region between constellations Lyra and Draco, an empty patch of sky where, for as long as we've looked, there has never been a recorded star. At first, it seemed like an error, maybe a gravitational lensing issue or a mistake in mapping. But when multiple systems confirmed the same path, the room fell silent. It wasn't a glitch. I-Atlas came from the dark between. That phrase, the dark between, quickly became the nickname for that part of the sky. A place where nothing should exist. No light, no heat, no source for what had come from it. But if it wasn't born there, then it must have travelled through there. And that opened an even stranger question. How? Objects traveling between galaxies are rare, but not unheard of. Yet 3I Atlas's velocity and vector didn't fit the normal signature of a wandering comet. It wasn't drifting through space, it was moving with intent. Even after leaving the sun's influence, it maintained stability that natural bodies shouldn't have. No tumbling, no disintegration, no erratic spin, just a slow, deliberate glide, as if something within it was still active. Some researchers proposed a radical idea. What if 3I Atlas wasn't just moving through the void, but coming from it? Dr. Rafael Cortez, a theoretical astrophysicist, summarized it in a single haunting line during an interview. This object didn't fall into our system by chance. It crossed a gap where physics itself begins to fail. Either something built it to survive that journey, or it comes from a place where our physics doesn't apply. His words sparked both awe and fear, because if 3I Atlas really came from beyond the known universe, then we were staring at evidence of a different kind of creation, one we couldn't yet define. Around the same time, the James Webb Space Telescope conducted a final, deep-field scan of the region from which the object had arrived. The data returned faint infrared traces, residual energy signatures that shouldn't exist in empty space. They pulsed, softly, almost, like an echo. When the data was played back and converted into sound, it produced a rhythm eerily familiar to anyone who'd followed the story since the beginning. A steady, repeating pulse, 72 seconds apart. It wasn't just in the comet anymore, it was out there too. This discovery triggered a quiet panic behind the scenes. If the pulse existed both within 3I Atlas and across the region it came from, it meant something larger, something connected. Perhaps the object wasn't the message, but the messenger. Some speculated that it was a fragment of a greater structure, a seed or shard from a civilization that existed outside our galactic horizon. Others believed it was a probe, designed to move between star systems, gathering data silently, waiting for light to touch it again. But one theory chilled everyone who heard it. A physicist from Caltech suggested the pulse might not be communication at all, but a clock, synchronization signal for something we haven't yet detected. If that's true, what is it counting down to? Meanwhile, across social media and late-night broadcasts, people began asking new questions. If 3I Atlas isn't from any galaxy we know, what does that make it? Is it alive, or just a vessel left behind by something ancient? Philosophers compared it to a message in a bottle, drifting across cosmic seas. But others saw it as a warning, proof that something beyond human comprehension had crossed the edge of our reality and chosen to reveal itself now. And yet, despite all the fear and speculation, one truth became clear. Atlas had changed how humanity looked at the sky, no longer as a vast, silent emptiness, but as a living ocean, full of currents we still can't see. Every new observation, every pulse, every unexplained echo whispered the same haunting message: we are not the center, we never were. As one researcher put it in his final report, if 3I Atlas truly came from between the stars, then we are witnessing the first evidence of something older than galaxies themselves, a traveler from before light. And yet, the deeper scientists looked, the quieter it became. No more pulses, no more thermal shifts, just silence. But in that silence, something lingered, a feeling that this wasn't the end of a story. It was the beginning of one we were never meant to understand. It started as a scientific mystery, then it became a question of physics, but now it was something else entirely. The world had given 3I Atlas a new name, the artificial comet. It wasn't official, but it didn't need to be. It was a name born out of wonder and fear. Across cities and deserts, people began looking up again every night. Telescopes sold out. Children pointed at the stars, asking if it was still there. And even though the object had drifted far beyond visible range, millions waited, hoping to see a single pulse of light. But the pulse never came. Weeks turned to months. The silence stretched longer than anyone expected. And in that silence, humanity began to change. On talk shows and podcasts, scientists stopped arguing about what it was. Instead, they began arguing about what it meant. If the universe could make something that looked, behaved, and adapted like a machine, then maybe intelligence wasn't a rare accident. Maybe it was inevitable. A pattern the cosmos repeated, again and again, until one day, something like 3I Atlas appeared. Some called it evolution on a cosmic scale. Others said it was proof of creation. But for the first time in a long time, science and philosophy weren't fighting. They were listening to each other, unsure which one was right. In universities, late-night seminars turned into quiet confessionals. Students spoke about how the discovery made them feel smaller, yet more connected. A professor in Italy summed it up perfectly. If the universe can give birth to a machine, maybe it's been trying to talk to itself all along. The line went viral, printed on shirts, quoted in documentaries, whispered in late-night radio shows. It felt like a truth people could hold on to when everything else felt uncertain. But not everyone found comfort in that idea. Governments began forming committees to monitor the long-term implications of contact. Religious groups divided, some calling 3I Atlas a sign of divine creation, others warning it was a deception, a test of faith. In the noise, humanity's reflections started to fracture, because every person saw something different in that silent traveler. Some saw hope, others saw warning, but all agreed on one thing: the universe suddenly felt alive. Meanwhile, in the scientific community, something remarkable happened. The data no longer inspired competition, it inspired collaboration. Astronomers, physicists, engineers, even philosophers began working together, not to decode the comet, but to understand the bigger question behind it. If the universe could create intelligence beyond biology, then what were we? Were we a coincidence of chemistry? Or just another link in a chain that's been repeating since the beginning of time? There were nights when observatories kept their telescopes aimed at the empty sky, even when they knew there was nothing to see, because the absence of a signal had become more meaningful than the signal itself. Silence wasn't just silence anymore. It was a message we hadn't learned to translate. And that realization began to echo far beyond the world of science. Artists painted 3I Atlas not as a comet, but as an eye, a mirror hanging in space, reflecting the light of humanity back at itself. Writers called it the witness. Musicians turned its rhythm, 72 seconds apart, into haunting songs that played on late-night radio, everywhere. The story became personal, because deep down, everyone knew this wasn't just about the comet anymore. It was about us. What if the universe wasn't indifferent? What if it was intelligent? Not as a being, but as a process. Every pulse, every rotation, every law of physics, a language we still can't read. And if 3I Atlas was part of that language, then maybe, for the first time, the universe had whispered back. Dr. Amir Kassem, one of the original data analysts from the early observations, spoke in a rare interview months after retiring. He stared out a window for a long time before saying, "People think we discovered 3I Atlas, but I think it discovered us." His words hung in the air like an echo that refused to fade, because maybe that was the truth. Maybe we weren't the ones watching. Maybe we were being seen. As the months went on, a quiet reverence settled across the scientific world. Atlas became more than data. It became a mirror, forcing humanity to face a question older than science itself. If intelligence can exist beyond flesh, beyond biology, then consciousness isn't a gift, it's a law. And if that's true, then perhaps the universe isn't trying to frighten us. Perhaps it's trying to remind us who we are, and so the world waits, still watching the dark, still listening for a pulse that may never return. Because deep down, we all know the truth. The signal doesn't need to come back for its message to remain. The message was never light, it was awareness. It began with silence, not the kind that fills a quiet room, but the kind that stretches across the stars. Deep, empty, infinite. Weeks had passed since 3 Atlas slipped beyond the sun's reach. The interstellar visitor that once pulsed with rhythm and light was gone. Telescopes searched the void where it should have been, and found nothing. No flare, no echo, no sign of movement, just darkness. For a while, scientists thought the story was over, that whatever mystery 3I Atlas carried had finally burned out in the cold. But the universe doesn't close its chapters that easily. One night, at a small observatory in Chile, a technician stayed past his shift, staring at residual readings from the deep sky monitor. It was supposed to be routine cleanup work, noise filtering, background calibration. But in the static hum of space, he noticed something odd, a faint pulse, barely visible, like the heartbeat of a dying star. He leaned closer to the data stream. Every 72 seconds, a blip. Then another, and another. The same rhythm, the same impossible frequency that had once echoed through radio arrays across the solar system. He thought it was interference, maybe a glitch, maybe solar radiation bleeding into the sensors. But when he compared his data to a separate array in Hawaii, the pattern matched. And again, in Italy, 3 observatories, 3 continents, one identical pulse. At first, no one wanted to believe it. The signal was too faint, too far gone. But the more they filtered the noise, the clearer it became. Not louder, just consistent. Every 72 seconds, a whisper from the dark. It didn't carry data. No modulation, no message, just a light, steady, patient, alive. And then the question no one wanted to ask crept back into the conversation. If the comet was gone, what was still sending it? Across the world, observatories turned their eyes toward the last known coordinates of 3I Atlas. They expected to find debris, a shattered shell drifting through space. But instead, they found motion, subtle, controlled. Something was still moving out there, not tumbling randomly like rock and ice, but gliding, as if guided by a purpose. Its path was precise, too precise for a natural fragment. It was following a new trajectory, one that led not away from our system, but parallel to it, as if orbiting from a distance. Watching, by now, public interest had faded. The headlines had moved on. Only a handful of scientists and skywatchers still cared. The ones who couldn't stop thinking about the pulse, the pattern, the unanswered questions. And yet, among those who did care, something shifted. It wasn't fear anymore. It was awe. Because 3I Atlas, or whatever it truly was, had behaved in ways that defied every rule we knew. It cooled itself near the sun. It changed its skin. It moved against gravity. It listened, and now, it refused to die. In a dim control room at the European Space Agency, a group of researchers stared at the final composite images, long exposure frames stitched together over several nights. At first glance, there was nothing but emptiness, but deep in the noise layer, barely visible, a small shimmer appeared. A flicker so faint it could easily be mistaken for a star, but stars don't blink in perfect rhythm. The pulse continued, precise, patient, eternal. One scientist leaned back in her chair and whispered, "It's waiting." No one responded. They just sat there, staring at the quiet light on the screen. Some said the signal was just a relic, a reflection from solar debris, bouncing light in a predictable way. Others insisted it was still active, still transmitting, but no one could explain the timing or the intent. And deep down, even the skeptics felt it, that low hum in their chest when they thought too long about what it might mean. If it was a machine, it had travelled across unimaginable distances, alone, silent, ancient. If it was alive, then it had chosen silence. And if it was neither, then what was it? Weeks turned into months. The data thinned out. The signal faded further into the cosmic noise. Eventually, even the most sensitive instruments could no longer distinguish it from the background radiation of the universe itself. And that's when the final silence came. Not a moment, but a slow fading, a quiet ending, stretched across time and distance, until there was nothing left to hear, just the faint echo of what had once been. Still, in certain corners of the scientific community, the mystery refused to die. Some believed that 3I Atlas was never meant to communicate, that the 72-second rhythm wasn't a signal to us, but a signal from something deeper, a cosmic metronome, a heartbeat of whatever sent it. Others thought it was a probe, one of countless others, scattered like seeds across galaxies, searching for light, for warmth, for intelligence, and maybe when it reached us, it found what it was looking for. Maybe that's why it stopped. Maybe silence was the response. But then there are the dreamers, the ones who still point their telescopes at the void, waiting to catch even a trace of that rhythm again. For them, it's not about proof, it's about connection. Because 3i Atlas reminded us of something we often forget, that we're not just observers in this vast universe. We're part of it. We send our own signals too, our satellites, our songs, our hopes, drifting through space, searching for someone to listen. Maybe, in some distant sky, another world is watching us, recording our light, wondering what kind of beings built a planet that glows at night. Maybe, to them, we are the anomaly, and so the story of 3i Atlas ends not with an explosion, but with a whisper. A silent rhythm fading into eternity, a memory written in starlight. It came from beyond the known, crossed our sunlit world, and left behind a question too big to ignore. What if the universe is speaking all the time, and we've only just learned to listen